Hi friends, welcome to my channel Olympiad Math. Today we are going to solve an interesting exponential equation that's been set in Math Olympiad. The equation is 8 power x plus 2 power x equal to 130. This equation can be written as 2 power 3 the whole power x plus 2 power x equal to 130. See, this is because, as you know, 8 is equal to 2 power 3. This means 2 power x the whole raised to 3. I'm switching these two. This switching is done based on algebraic identity. As you know, a power m the whole raised to n equal to a power mn. Now you know m into n is n into m. So nm equal to n the whole power n. See, we are switching these two and we are getting the same as a power n the whole raised to m, which is what we have done here. Now this equation can be written as, let me substitute y for 2 power x, y or any other variable. So if you take y for 2 power x, this is what you are going to get. Bring 130 to the left side. It will become minus, as you know, where y is equal to 2 power x. Now this is a cubic equation which has, as you know, at most 3 solutions or roots. You find out each solution and substitute here. Then this simple equation using the principle of logarithm, see, you can write it. Let me interchange the positions of these two. 2 power x equal to y. Now, keeping x, how do you take 2 to the right side? We are actually making use of the basic definition of logarithm. This implies x is equal to log y 2. I hope you're familiar with the definition of logarithm. We are applying that here. Now, there is something you can observe. See, x is the final variable we are solving for in this equation, and x has now turned into a logarithm of y to the base 2. Now, as you know, logarithm is defined only for positive real numbers, which implies y has to be greater than 0. What does that mean? See, y is finally something you're going to get from this cubic equation. Solving this cubic equation, as I said, you will have maximum 3 solutions or roots. And if the solutions are positive, you can apply here. Supposing you have negative real roots or complex roots, we don't need to apply that here because logarithm is defined only for positive real numbers. That's what I mentioned here. Now let's come back to this equation. Y cube plus y minus 130 equal to 0. See, in all higher degree equations, I mean higher degree when I say anything above quadratic equation, at Olympiad or SAT level, one of the roots or one of the solutions will be an integer, which you can easily identify by just looking at the equation. So all you need to do is just plug in integers like say plus or minus 1, plus or minus 2. You try a couple of these integers. And in this case, you don't need to waste time trying out negative integers because y cannot be negative. So all you need to do is to find out whether there is any positive integer satisfying this equation. You can easily see that y equal to 5 will fit into this because when you substitute y is equal to 5, what do you get? 5 cube plus 5 minus 130. This is 125 plus 5 minus 130. This on simplification turns out to be 0. What does that indicate? Y equal to 5 is a solution for this equation. And it's a positive solution. Moreover, it's a positive integer. We should look at all positive real numbers as are given here. But positive integer, of course, is a positive real number. So we got one solution. Corresponding to this solution, y has been taken to be 2 power x. So what do you have? 2 power x equal to 5. Then using the basic definition of logarithm, x will be log, and this is the final solution to this given equation. The problem is over. To do this, I had thrown down a challenge to you that this is solvable in less than a minute. All these steps you can write in less than a minute and arrive at the solution. Now, there remain a few other points to be discussed here. Let me take you through those points because, as I said, we've got only one solution. There are two more solutions. Supposing those two solutions are positive real numbers, definitely you will be getting two more values, two more solutions for the variable x. But look at this cubic equation. We can write it like this. Fy equal to 0, where Fy, it's a third degree polynomial, this function, y cubed plus y minus 130. There is a rule called Descartes rule of signs. These signs indicate plus and minus. I will explain to you this rule of signs with reference to this particular equation. See, I can't go deeper into this rule. Just for this equation, how does this rule apply? That I'll show you. See, basically, this rule is used to find out the number of possible negative and positive real roots of a nth degree equation. This is a third degree equation. Now, if you take Fy, look at this. This is the third degree polynomial. When you equate this to 0, you get the given equation. Now, if you look at this polynomial, see, here it is plus, then minus. So, plus turns into minus only once. Plus is going to plus, no change. Here plus is turning into minus. So, there is one sign change. Sign means plus into minus. There is only one sign change. That implies this equation. Rather, when you equate this to 0 is what you get the equation. That equation, y cubed plus y minus 130 equal to 0. Let me write it again to make it understandable to you better. This is the corresponding equation. This equation has maximum one positive real root. This indicates what? This can possibly have negative roots. As I said before, we are not interested in the negative value of y because finally you are looking at log y, and logarithm is defined only for positive integers. But you can prove that this will have no negative solutions. Anyway, it's not needed for this problem, but let me give you some ideas about finding the negative roots of a given nth degree equation using this Descartes rule of signs. All you have to do is you find out f minus y. How do you get this? Putting y equal to minus y in this equation. So you have minus y cubed plus minus y 130. All I've done is y being replaced by minus y. And then simplify. What do you have? Y cubed minus y. Number of sign changes is 0, which indicates this equation has no negative solution. So there is only one real solution for this equation. So what about the other two roots? Definitely the other two roots are complex or imaginary. It has one positive real root and the other two roots are complex. And there is no point wasting your time finding that those complex roots because ultimately x is equal to, see, we have shown that to be x is log y to the base 2. Can you see that? So x log y to the base 2 equal to log. See, this is going to be a complex number and a logarithm, as I said before, is defined only for positive real numbers. So y has to be positive, which it is not if you look at the other two roots. So this indicates what? This equation has only one positive real root and corresponding to which you have got this as the solution. So this is the final answer. See, to conclude these points, you should know the basic definition of logarithm and also the Descartes rule of signs. If you're well versed in the basic concepts, you will be able to move smartly and shorten the time needed for tackling any problem. So all you have to do is be thorough with the basic facts. The facts we need, or rather the concepts we need, I have taken you through in this solution. So to do this from the beginning till this point, all you need is, like I said, just a little less than 1 minute. And this is the challenge I had thrown down. So I hope you understand this problem is solvable in less than a minute. By the way, if you're more interested in this rule of Descartes, please let me know that in the comment section. I'll be able to show you a few more problems with the application of Descartes rule of science. Hope you found this video useful. If you found it useful, please like and subscribe to my channel and also share this video with anyone who you think might benefit from the solution. Thanks for watching.